Hey guys, welcome to lecture 7. I guess not really lecture 7 if you don't include the last lecture, but today we're going to be talking about authentication, which I think you guys will really appreciate if you guys are using any sort of external APIs like Google or Yelp in your Hack Challenge project. Just some logistics, you guys should all be on a team. You should have submitted like one of the forms, and your mentors should have reached out to you by now about midpoint meetings and general like mentoring things. If that hasn't happened for you for some reason, come up after lecture and we'll try to get that sorted out. All right, so let's talk about what we've learned so far. So far, we know how to set up and run many different types of simple Flask backends that have basic functionalities like social media or like a CMS or Venmo. But how have we incorporated users thus far? Let's think way back to what happened in PA1 when we had our Reddit style app. Whenever we created a post, we only referred to a user in passing. We would just pass in the username as a value in the body. But what's wrong with creating users like this? Well, anyone can impersonate anyone else. If you're the one creating the request and the server kind of blindly says, oh, well, you said that your username is Alicia, you must be Alicia, but you can kind of put in whatever person you want, and the server will just take that. So you can see that there's a very, very, very high security risk, and no one should ever actually do this if you want real people to use your app. So today, we're going to talk about how in any application with users, the application needs a way of actually verifying who you are. So the process in which we do that is called authentication. So when we're making requests to a server, how's the server going to know, one, who you are, and two, like validate that you are who you say you are? So authentication is a process that ensures and confirms a user's identity. So let's go through a really quick example. Say you sign up for an account on a website, and the website is going to store your credentials securely through hashing. So they're not going to ever store, like say if you send your email and your password, they're not actually going to store your password in plain text in the database. That would be risky if a malicious user manages to get access to the database. Instead, we're going to hash it, encrypt your password, so when it's stored, even if they have the database, they're not actually able to figure out what the password is. So to access your account, the client would, aka you, would send over your username and password, and what's going to happen is that the database on the server is going to check, oh, well, let's see, oh, the username is in the database, and we want to make sure that the password that you inputted is going to be like the same like hashed password that's associated with that username. So for this example, we can talk about Facebook. On the left, you have the login and the sign up page. And let's say that Facebook will have like a few databases. When you first sign up, you're going to fill out things like your name, email, and password. And then this Facebook client is going to send the encrypted credentials to the database and store it there. So that way, once you've successfully created your account, when you log in, you'll put your email and your password. That's going to be sent over to the database again, and that's where we're going to check, okay, is the email there? If it is, then let's check that the passwords match, and if so, then your credentials are good to go and you will be logged in. So there are two main types of authentication. We have HTTP basic and HTTP session authentication. So session authentication is used more commonly than basic authentication for a few reasons that we will talk about shortly. So the general gist of how basic authentication works, first you're going to send over your username and password to the server. If your login is successful, then your browser is going to cache your credentials. So it's going to save like your username and password for that site. So whenever you make a request to the header, like going to a page, the credentials are going to be sent with the request saying that, hey, it's like Alicia that wants to get her posts. So what would this look like in the request? Let's say that you have an endpoint on Google My Files that will, maybe this is on like Google Drive or something, where you want to access all your files, but only you can access it and no other account. Here you can see there's this extra metadata. So if you remember, the request will have like a body, but in addition, it might have something called a header. And this header will contain all like the metadata associated with the request. Authorization is one of the key words in this metadata, and that's where our like credentials will go. So you can see here, it says authorization, and the value attached to it is first basic, and that's just saying, hey, we're using basic authentication, and then an encoded version of your username and password. Now, note the difference between encoding and encrypting something. Anything that is encoded in base64 or in general can be decoded. So you can take that string right now and go to like a decoder on Google or something, and it'll tell you that that is foo-bar. It's usually done for kind of like almost obscure reasons, and it'll like shorten it or something like that, but it's not safe. If you're using basic authentication with HTTP, nothing is encrypted, so anyone can look at the network traffic and, you know, if they see this request, they can figure out from the header what your username and password is. And that's kind of why we don't like using basic authentication. So security risks, your username and password are exposed in each request in the header, and there's no good way to say like log out. Your credentials are going to be stored until you close the browser or the user clears their history. So that's kind of like a lot of work for the user, and sometimes you might be logged in for longer than you might desire. So what about session authentication? This is the counterpart to basic authentication. So what is a session? A session is a time frame when a client and server are interacting. I like to think of it like if you go to Six Flags and you have to buy like a day pass, you get a day pass and you're able to, you know, get all the resources from Six Flags, aka go on all the rides, until that day pass expires, you know, maybe at like 5 p.m. Then even if you use that same ticket, maybe the next day, they're gonna be like, no, you have to buy a new ticket. So sessions are gonna be stored as a separate table in the database. They're gonna be associated with one user. So each user is gonna have like a one-to-one relationship with a session. And each session will contain generally like 3 things. One of the things not on here is a session token. That's just like a unique identifier for a session, like a name for a session. We'll have an expiration date saying, oh, well, you can't access this anymore after this time. And then we'll have a refresh token, and we'll talk a little bit more about that later. So this is what it might look like in a table. Say this is a table representing sessions. We'll see the things highlighted here are some of the things I just talked about. We'll have the session token. We'll have expires at, which is the expiration time. We'll have an update token, which is the refresh token. And then you can see at the very bottom, we have a reference to a user. So here's like our foreign key saying, well, this session, this ticket belongs specifically to this person. So what does the authentication process look like for session authentication? You'll have the client sign in, as usual, with the username and password, and then this will be sent to the server. It's going to check, okay, these are valid credentials, and then after the server's like, okay, you're good to go, the server is going to create a new session and return the session token for the user to use. So this is kind of a diagram of how this communication looks like. You can look at it from top to bottom. So the client would be like, here's my credentials, and the server will say, okay, you're good to go. These are valid. We're going to send a response, and that response looks like a session. And the session token might be like string ABC. And the cookie is here is just saying that once the client gets this session token back, it's going to save it as like a browser cookie. So that's what I just said here. The client will store the session token as a cookie or on disk securely, and then it'll use this session token with every single request to the server, so the server can recognize the user. So just like in basic authentication, where the client will send over the username and password with every request. Now we're just only sending over the session token and not your username or password. So that's this part here. Say that you want to get your profile. You have this cookie that has your session ABC. You're going to send it over, the whole thing, the request to the server. The server is going to say, it's going to look up the session token in its session table, say, okay, this is valid. And then only then will it give you like the intended response for get profile. If the server sees that the session token is expired or doesn't match the user or whatnot, then it will give like one of your normal error responses, maybe like a 401 unauthorized. Yes?
Is the session token encrypted, or like is anyone who has it just send it and log into your session?
If you're using HTTP, they can see it, but because it expires, even if they somehow like get access to it, they only can use it for a short amount of time. And they would still need to know your like username and password for a lot of different things. Okay, so again, tokens are designed to expire after a certain length of time. So, if somehow someone gets your session token, then they're only going to be able to use it for a little bit. And after it expires, users can either request new session tokens, or we can use the refresh token I mentioned before. So if you have a session token that's expired, what you can do is send over with a request a refresh token, and the server will be like, okay, I gave you this earlier to give to me whenever your ticket expires. So I'm going to create a new one for you so that you can continue using my services a little bit longer. So once you send over the refresh token and the server recognizes that this is a valid one, then it's going to send back a new session token, a new expiration date that's going to be later than before, and a new refresh token. So why do we want to use this? Well, now our request only contains the session token, so the usernames and passwords are no longer exposed. And they're going to expire, so they're not like a ticket forever. Yep.
So with apps that you're like permanently logged into, I mean you can log out if you want, but if it defaults to like keeping you logged in, how would session tokens work with that given that they expire?
Your expiration like expires. That might be like really, really big. So I don't know. They set it for year 3000 or something.
Yeah, so they can also do a thing where they give you two tokens actually. So one token will be intended for like your general requests, and that one will have like a shorter period. But then you have a second token called like a refresh or access token that will serve to get you new versions of the other token, and that one typically has like a longer refresh period, like weeks, months, or days, and that they trust they don't use it in any requests except for that one, so they're limiting like the vulnerability of it getting stolen. But yeah, so you can do it with like multiple tokens.
So how do we design this sort of HTTP session authentication in our very own apps? So like I modeled before, we would have a sessions table in our database, and it would reference a user via a foreign key. So if we were to write this as a SQL command, it would look something like this. It's pretty standard. It'll have all the fields that I mentioned earlier with ID, session token, expires at, your refresh token, and then note that you have the user ID that points to a user in the users table. So say that your client will give you your session token. How exactly, like on the server side, will we make sure that it's like a valid session token? First, that you would select some sort of like user ID from your sessions where you have the session token equal to the one that the user set. So hopefully, if this session token is in your sessions table, you will find the row associated with it, and then you will find the user that is associated with that row. Once you have the user ID, then you can just look in your users table and say maybe this is like get profile. You want like a lot of the information from the user, then you can select everything from user given a valid user ID associated with the session token. So another type of authentication that's very popular, especially when you're integrating with other third-party apps, is called OAuth 2.0. 2.0, I think, is like the current version. So you guys have all interacted with OAuth 2.0, I'm sure, if you've ever logged into anything that's not Facebook or Google with your Facebook or Google account. Maybe like Spotify. So an example of this is like Pinterest. You can create a new Pinterest account, or you can just continue with Facebook and Google, where you don't have to put in your email and you don't have to create a password and I guess put in your age for some reason. So there are 3 different types of parties that are associated with OAuth, and I think they make sense. First, you have the application you would like to sign up or log into. In this case, it's Pinterest. You have users, which would be you, and they're called resource owners. And then we have the API resource server. So this is like the app that you're using, like your account, to sign into Pinterest with. So that might be Facebook or Google. Users are called resource owners because you can think of users as owning the Facebook account, owning the data associated with the Facebook account. And then Facebook or Google is a resource server because Facebook or Google are going to be providing Pinterest with like some of the users' data. So why use OAuth? It streamlines the user registration. It's really easy. It's just like 1 click, maybe 2 clicks. It minimizes the number of accounts for users, so you don't have to have like a million different usernames and have like a fancy new password for each one. And maybe not a benefit for the user, but benefit to the resource server. The umbrella account provider will gain valuable data from you. So maybe Google now knows that you use Pinterest and Google can do its things with that data. So how does this work? High level. First, your application is going to have to register itself with the resource server. So say that you're the developer of Pinterest and you want to be able for users to log into your app, Pinterest, with Facebook and Google, or I guess Facebook in this case. So Pinterest will register itself with Facebook. It's going to implement however Facebook uses OAuth. And then from Facebook, Pinterest will get a client ID and client secret. So what these allow Pinterest to do is that whenever Pinterest communicates with Facebook to like authenticate, that's how Facebook knows it is Pinterest talking to them and not just like some random sketchy app. In addition, Pinterest will declare to Facebook a redirect URI. So URIs are kind of like a superset of URLs. It's just like a resource identifier, in this case kind of like a link. And Facebook will use this URI to redirect the user back to Pinterest after the user signs into Facebook. So you guys have all done this before. You're going to say, okay, continue with Facebook or Google, and then they're going to say, oh, do you give permission for Pinterest to see your friends and your timeline? And you say yes. And then you don't stay on Google afterwards. You go straight back to Pinterest. That's what the redirect URI is. Finally, we have the code generation. So this code is for Pinterest. So Pinterest will have a button that will say like continue to Facebook, and it will link to something like this. It'll link to a Facebook URL, and it'll say something like auth, so you know it's going to its auth endpoint. And it's going to send a few things with it so Facebook knows what's going on. So first of all, it's going to say that the parameter response type is a code. So Pinterest is expecting a code to be given back, like an authorization code to be given back by Facebook. It's going to send its client ID to tell Facebook, hey, it's me, Pinterest. And then it's also going to send the redirect URI saying, hey, go back to this link after you're done authorizing me. And then, this is pretty interesting, Pinterest will specify its scope. So you can see here it says friends and timeline. This is Pinterest's way of telling Facebook like how to specify what resources Pinterest wants from Facebook. This is a good thing. That way Pinterest doesn't get literally everything you have on Facebook, because Facebook only wants Pinterest to have a few things. This is kind of like access control here. So Pinterest might want like your friends, seeing, I don't know, what your Facebook friends are interested in as well. and maybe Pinterest wants you to be able to share like Pinterest posts onto your timeline. So Pinterest is going to say, hey, I want access to your friends and timeline. Finally, it's going to specify like a state, which is kind of just like a generated string for security reasons. So once you log into Facebook and it's successful, the user will be redirected to a URL that looks like the following. So this now goes back to Pinterest, and with it is going to be an authorization code provided by Facebook. So this is Facebook's way of telling Pinterest, okay, I recognize this user. This user says it's okay for you to be able to access their account and these specific resources associated with the account. So here's an authorization code that you can give to me later whenever you want stuff from me. So in a diagram, these past few steps are represented in like the box above. You have our application Pinterest talking to Facebook and basically you whenever you log into Facebook. So Pinterest is going to have the authorization request, and then you will log in and you'll tell Facebook, I want all of these things. And then once you log in, you give the authorization to Pinterest to connect to like Facebook to receive any of the resources specified. So now that you have an authorization code, this can be used to fetch a session token. So these session tokens don't grant access to Pinterest. It allows Pinterest to have access to Facebook services. So to get this token, Pinterest might make this request to Facebook saying, hey, I have this code. It's an authorization code. That's what I specified with grant type, and the code is put there. And then again, we have like the redirect URI, client ID, and client secret to make sure, again, this is Pinterest. So once Pinterest has this access token, you can think of it as like the session token. So now whenever we have something like, oh, get me all of the user's friends on Facebook, Pinterest now has that access with the session token to go to Facebook and say, hey, I want to make this request, and Facebook will allow you to make that request. So yeah, does anyone have any questions? OAuth is pretty confusing, but generally for any specific like app that you want to use OAuth with, like Facebook or Google, they have pretty good documentation online on how to set that up for your app. All right, Connor's going to be doing the demo.
So getting into the demo, we will not be demoing OAuth, but we'll show you a good way you could implement session authentication on your Hack Challenge project if you so choose. So we gave you some starter code on Piazza. There's actually like a lot of starter code with this one, so if you'd like to follow along, we highly recommend you download this right now. But I'll give people a moment to do this if they want, and then we can jump into our code. Let's see. All right, cool. All right, cool. So looking at our starter code, we have 3 files for you to work with. So we have app.py, db.py, and then also this new users DAO.py file that we'll talk about later. But to start with the db.py, this is like one possible implementation for using session authentication. So things to notice here is that we actually have embedded the session information directly into like a user model that we've defined instead of creating our own session table. We can do this because we know that we want session tokens and sessions to have a one-to-one relationship with users. So at any given point, a user will have one and only one session. So it allows us to kind of merge these two into one and then just have some logic for updating these tokens as part of the user model versus editing rows in a separate table. But the first thing to notice in our user class that I like to highlight is this password digest. So this like extra digest flag actually just we're indicating that we are encrypting our password. So if you look at init right here, when we initialize this, we use this package called Bcrypt that was imported up at the top. But Bcrypt is a popular Python hashing library, and in this case, we're going to use their method called hash password, hash PW, and we'll just take whatever argument we get in from the password and then encode it in UTF-8 to make sure it works okay, and then we'll apply whatever Bcrypt hashing algorithm we want on top of it. But another thing to note about hashing, also for reference, for people who haven't heard of hashing before or aren't too familiar with it, it's basically just a process of taking some string or other piece of data and then totally scrambling it in a way into like a unique identifier, but scrambling it in a way where you can't inverse it to get back the password. So if I hash like say the string hello world and I have this hash that represents hello world, I have no way of knowing like what string could have created that hash from the beginning. So that's why we use them instead of encoding, because if we were to encode it, then someone who could steal this could decode it and find your actual password. But along with like general hashing practices, industry typically does this thing called salting. So that's what this Bcrypt Gen Salt is doing. And the process of salting is like the motivation behind it is there are lots of popular hashing algorithms out there, and you don't want to get caught like someone like say like there are like 10 most popular hashing algorithms. People could just like take what like guess passwords by hashing it on those popular algorithms and like directly checking those with like SQL injections or something like that. But by salting, you add like additional strings to the provided string before hashing it. So say someone put in their password hello world, we would add a salt, say like an exclamation point 227 at the end of the string and some other like at character at the beginning. So like those are called salts, and then we would hash that entire thing. And so like the purpose of salting then from our perspective is we can add our own personalized encoding before we hash the message so that hackers or people out there who are malicious cannot apply like the general hashing algorithms that are out there and try to guess our password manually that way.
So what does 13 rounds mean?
Yeah, so that means we're going to do this 13 times.
So like you hash it and then rehash it?
Applying, so I'm not too familiar with like the internal settings on Bcrypt, but it's just a way for us to indicate like what level of salting we want to do. And there are other custom settings we could probably provide of like directly, like if we wanted to add our own like personalized string, we could just add that like something like here, like plus like some stuff. But Bcrypt gives us this gen salt thing that's like more rigorous than anything we could really want to do ourselves. Yeah. Cool. So then along with hashing and adding our salts, we also want to bring attention to the session expiration. So SQL Alchemy has a datetime object that we didn't show you before, but we just want to show you that, hey, like this thing exists. Instead of just using like datetime objects and then casting them as strings all the time, you can actually use a full datetime object. And for our tokens, we use this method here using hashlib, the SHA1 algorithm. So this just gives us a random string of 64 digits long, and then just using some other hashing things there to generate these unique strings for us when we pass tokens back and forth. And another note if you're not familiar with Python, this underscore in front of the method indicates that this is like a private method in the class, and that what this means is when we call this method, we only want to do it internally within like other methods that we'll define in this class. So like if we have an instance of a like user object, we don't want people to be like allowed to call user.url safe base64 because like that has no purpose to it. So we only want to use this method purely within other methods we'll define in the class. So along with this, we have some other methods we've defined for like renewing session, but for verifying passwords, we'll use Bcrypt's check password function. So all we have to do is take in a password for the method, and then we'll encode it and then indicate the field that we'd like to check the password onto, and then it'll know because of how we hashed it before, it'll check for us and verify that the password that was inputted matches the hash that we put in the database for that specific field. Yeah. And then the renew session method, some things to know about this is when we call this, we'll be generating and storing brand new session and update tokens. So in the case where we would want to use this is say we have a session token that in our case it's only going to last like one day, indicated here with like the datetime time delta object. So another note, datetime is a very popular Python library for working with dates and times, as the name implies, but when we create our session expirations, we'll be making them for one day at a time. So the renew session method will be called once one of our tokens has expired and we want to get a new one. Upon triggering like that return of the new ones, we want to give ourselves a completely new session token with its expiration, and also a completely new update token, so that our update tokens are only like a one-time use basically. So maximizing like the amount of like minimizing the number of vulnerabilities we have associated with the long-term token. Yes, and then we'll use these methods later as we add stuff to our code to implement authentication. But for now, we will move into users DAO.py. So DAO, for reference, stands for Data Access Objects. This is another popular thing we can do in industry where we have like very common things we do all the time, like in our case, like namely like querying users or interacting with the database consistently in specific ways. We can abstract some of that and create our own custom methods that like clean up some of our code when we're doing these things repeatedly, but also like as you scale like a massive application and you have many developers working on the same thing, you may not want every developer to have direct access to do anything they want in the database. And by providing these methods for them, you can like limit their like range of freedom for messing with the database, and you can make sure that they use these predefined operations on your database. Yeah. So for us, we will start with the create user for initializing everything. But for us, the first thing we want to do is we can see if we already have a user in the database. So we can say like an optional user is going to equal, we can use like call like this method. So get user by email, and we can pass in this email right here. And then say if this optional user is, if we don't have one, so if it doesn't exist, then we can return false, so that as in so for reference, we're going to return a tuple indicating if we created a new user, along with if we like that actual user object. So in this case, if one doesn't exist, so like we want to do like this: if we have one, we didn't create a new user, and we're going to return that the current user that already exists. So then we can create a new user if we want from the class that's already been imported up here. So we can say, hey, create a new user with email equals email and password equals password. And so notice how we defined before our init function for the class is it'll automatically hash this password with Bcrypt's algorithm. So for constructing the user, this is all we really have to worry about. And then once we've created this, we can just add this user to the session, and then we can commit these changes to the database. And then after this, we want to indicate that we return that we created a new user with true. We'll use this logic later, along with this created user. So now let's go on and actually use this in, say, like a registration method. So in app.py, just some things. We're still using like Flask and SQL Alchemy the same way we've used it before, defining a Flask app and all these configuration things at the top. Still initializing the database as we did before. But let's move forward with account registration. So the first thing we want to do is just like get our post body, because we are expecting a username and password field, potentially among other things. So we'll load in our requests data, and then let's parse the email out of this post body along with the password. And so the first thing we want to do is just like add some extra authentication if email. So like if we don't have an email, so if it's none, because if the post body dictionary doesn't have the email field, .get will default to return a none value. So if not email or not password, then we want to return, hey, like this didn't work well. Please give us all the data that we need. So we can return an error, say invalid. All right, now just say like missing email or password. So now let's actually create or see if like our user already exists in the database by calling this method we just created in users.dao. Also note imported at the top here, that's where it's coming from. So the method we just created was create user, and we can just provide the email and password taken out of the post body. So now we know if we didn't create the user, we can just say, like, hey, we're not going to create a new user for you. There already exists a user, so we can return something like this. User already exists. But otherwise, else we can just return this user. Well, actually, funny thing here. So upon registration and also upon login, we don't want to just like return the user object like we've done with like routes that we've already implemented in the past, but rather we want to give them the tokens that they'll need to actually interact with their database from here on out. So we're going to have a more complicated return statement here, but we can just say, let's expand this. Come on. All right, so we can say like, hey, we have a session token, and the user that we just created has a session token object. We can also say like, hey, this when it's going to expire, so user session expiration, and then the update token field as well. So also note that before and how we define the database, the session expiration is actually a datetime object, so we need to cast it down to a string just with using this str for us, so we return only basic types in this dictionary back to the user. Yeah. Cool, so the next thing we want to do is this method that we'll define that actually doesn't have a route, but one thing that we'll want to do with every request that will interact with the user is extracting the token from the request and seeing if it actually matches with anything. So we can abstract that logic out here with a helper method. And the first thing we want to do is actually parse the headers. So as Alicia mentioned earlier, with every request, we're going to use in the headers metadata, we're going to provide like a bunch of key value pairs. So the key value pair we're expecting right now is authorization as the key. And then we want to check like, hey, was this header provided? So if no auth header, then we can return no token, and along with this. And this may not be extra clear right now, but once we show like how we implement and call extract token, it'll make a bit more sense. But we can say, hey, you're missing an authorization header.
Make sure that when you grab this key value, aka like authorization is capitalized, just because that these are kind of like conventional metadata keywords. So sometimes if you don't capitalize it right, then you won't get anything.
No. All right, so the next thing is, here, actually we can show you on Postman, but wow. All right, so in any request, so you can see in like Postman we have all these tools, but we can look at the authorization tool right here. So Postman has like many options for us, but for us we'll be using a what's called a bearer token for this. And what it does is it allows us to actually like define authorization headers automatically through like this little interface. But so if you see, where'd you go? Oop. Okay, well it's not showing up here, but it will show up if we actually send a request. But this authorization will automatically generate a header for us, and it'll look something like authorization, and then it'll have this keyword bearer, and then a bunch of whatever like characters representing our session token. So the next thing we need to do is actually anticipate this bearer and parse it out of the string that we'll receive from the request header. So we can do that by saying like bearer token is going to be auth header, and we can replace, do some like fancy Python stuff, bearer with the empty string. So if the bearer string exists, we know it's going to be at the front of the string, just replace it with the empty string. And then if there's like any leftover like empty spaces, we can just like strip them from that using just like some other built-in Python methods. But like before, if we want to make sure that we have a bearer token that's worked properly. So if not bearer token, then we can return, and we can just copy this from above, But then otherwise, we have our bearer token, so we're happy, and so we can return it like so, indicating that everything is good with us, and here's the token for you. All right, so like possible example of where we'd want to use this extract token method that we've created is, say we have like this method at the bottom, this route secret. This just indicates like any possible route you'd want to allow users to like interact with the database with, but it's just like it's arbitrary for our purposes right now. But we can actually get a token to start off with, so let's see if it worked properly. So success, and then the actual session token is going to be able to be equal to this extract token method, and we can just pass in request. So note, like, don't be alarmed that this request isn't actually like defined locally anywhere. Like, it's not taken in as a parameter for the method, but it's something that Flask gives us by default, and you can see it up here from the imports. And so Flask, it's very nice part of the ORM is like making it clean for us to give us a request object within each route that will give us all of this metadata that we need to parse and work around with. So for us, like, hey, if success did not work, we can actually just return what we did before. So although I'm not actually returning a session token, I'm just like saving us some steps here by earlier we defined, hey, if it doesn't work, then just return the error message for us. So we're just kind of like saving ourselves from some extra logic and just immediately returning that. But otherwise, if things did work properly, let's see if we can actually get our user. So we can do users DAO, and then this other method called get user by session token, and then we can just provide the session token here. And so if this user does not exist, or the user's token is not verified, as in like the date is it's expired already, then we can just return a failed response. But then otherwise, we are happy with our user login and authenticating the session token. So we can just say, you have successfully implemented session tokens. So right now, we're going to test to see if all of this is working properly. Seems like people are still writing. Okay, we're going to go on. But if we do Python, we're first going to need to install everything. Oop. Oopsies, I didn't vend for 1 second. All right, there we go. All right, cool. So we're running the application just like we did before, and we can go ahead and check our registration route. So we're going to make a post request to localhost 5000 slash, what was it? Register. And in our body, oh, let's get rid of this first off. But in our body, we can just provide some like raw JSON data, and we'll provide a username and password, email and password. So we can just say js123 cornell.edu, and our password can just be abc123. Cool. And let's see if everything goes. Cool. So as you can see, it returned us a session token, an expiration date with very precise measurements, but and an update token for us. So now let's see if this will actually work. Let's see if we try it again. It should be like, hey, we already exist, so that's good for us. All right, next we can try if we do the secret route. And this route is /secret. And so for us, the authorization, we're going to use the bearer token. And let's see, so first, Actually, let's just see if there's no authorization. Like, what happens if we hit this route? Ooh, not happy. Oopsies. Get route. Cool. So it's like missing authorization header, so that's good because we intentionally didn't provide any. So now if we add the spare token, say we want to use an improper token though, we can check if this is working. It is, invalid session token. But now let's actually provide the proper session token. Oh, shit, I didn't copy it.
Create a new one.
Oops. Alright, we'll do JS1234. Aha. Got him. Alright, cool. So now we have the session token. We go in, successfully implemented session tokens. Bravo, we've done it. So now we can continue on and show how we can do some other routes like logging in and stuff like that. But first, any questions about what we've gone through, any of this logic? Once you have like the initial setup of like the database, everything becomes somewhat straightforward and boilerplatey, but we want to take you through how we do some of these basic operations that you'll need to do if you want any like authentication. Cool, so next, say we want to implement our verify credentials method. So we could say, hey, let's get our optional user, and we're going to get our user by email because that's all we have to identify them right now. So actually we can just like copy this stuff. So if they don't exist, they give us nothing back, but otherwise we can do optional user, and we can call this method verify password. That was provided in the db.py file. We can give back the password, and this will return a boolean saying like true or false, and so and then we'll return our actual user object. So now if we actually want to look in at some of the logic that's happening when we call .verify password, if we go to db.py, this is what's calling the Bcrypt check password method. So we don't need to dive too deep into what this is doing, but it's just like basically taking our password, hashing it according to like how we defined previously, seeing if the hash that was created from this password aligns with the hash that's stored in this user's password digest field, and then returns if they match or not. But now we may want to use this when we log in. So if we go to the login route, we can say parse the post body how we did before. So we can just grab some of this. Yeah, that'll be good for now. We're using some of that logic. And then otherwise, let's see if we can authenticate our user by doing users DAO, verify, not password, credentials. And we'll pass in the email and password parsed from the request's post body. And then if this doesn't work, then we can just say you're not authenticated properly. And then otherwise, if this did work properly and we got a successful login, we can return like before with verification, with the registration. We can just return the session token being the user session token field, along with the session expiration. I'm going to cast it again to a string because it's a datetime object right now. And then the update token if necessary. Cool. Yeah. Alright, so let's see if we've logged in successfully and we have all this working properly. Postman, we go to local 5000, login, and the post body, go raw. Ooh, wrong thing. JSON, so before we had John Smith 1234, Cornell EDU, and then password, oh, this is key. Password was ABC123. Let's first see like what happens if we provide an incorrect login. Ooh. Invalid syntax.
That was because you saved halfway through.
Oopsies.
Now you can just restart it.
All right, let's see. Cool. Oh, that's not what we want. Thank you. That would make sense. Cool. Error. Incorrect email or password. Wonderful. All right. So now if we do ABC123, we get also incorrect. Oh, that's not what we want. All right. Okay, let's try John Smith 123. Also not correct. Uh-oh, SpaghettiOs.
Wait. I think you did if optional user instead of if not optional user.
Ta-da. Thank you. Cool. Bravo. Nice. All right, cool. So now I have a session token, and we can check our secret route just like this before with the new session token from the other user. It's like, hey, did it properly. Say we did. Yeah. Cool. Everything else works properly. And now we can see like, hey, what if we have a session token, but it expired? Let's go through the process of renewing a session token. So back in users DAO, this last method here, renew session, we can begin by just get our user. Actually, we know we'll only call renew session when we know that we actually want to renew everything. So we can just use this method we've defined up here, get user by update token. So we're just saying user query filter. This field is equal to the update token, and we want to get the first person with that, even though we know it's going to be unique. We use filter first to not throw an exception, because filter first will give us an untype versus get will just like throw an error if it doesn't exist. But we'll get user by update token, provide the update token, and then if no user, let's actually raise an exception for fun. Invalid update token. But then otherwise, we can do this user renew session method in the database that we'll go to, but we'll save these changes for now and return our user. So the logic of what's actually happening when we do user.renew session, we can look in db.py. So as mentioned earlier, we just create two completely new tokens, set those attributes for the user, and then create a new expiration date as well. And then we save that change, and then we can return that user back. So now this final route for us would be updating the session. We can parse, we can get our update token like this, extracting the token, the request, and then if things didn't work well for us extracting, we can just say we're not actually returning a token here. Based on how we define extract token, remember that this is actually a failed response if success is not good. Ooh, you shouldn't be there. And then now here, because we raised an exception earlier, we can just put this within a try except if we want. So users DAO, and then let's renew our session with this update token. And then if we encounter an exception, we can accept and return a not so happy response. Error, it's going to be invalid update token. But then otherwise, we got our token properly. We got everything we need. We can dump just the same old session token, user.session token, session expiration, and this one. Nice. All right, cool. Let's see if this one, last one works for us on Postman properly. So we want to hit the /session route with the post request. So let's take, we have this old update token, lovely. Session, post, body. and then we can pass in our, we just want email, JS123, ABC123, and then make sure authorization is working properly with bearer token, paste this update token from the previous request, and boom, we got a new one. So we saw before it was like 5A4C, we got back a new one. So say if we, let's copy this before we don't lose it, but if we make this request again, this old update token doesn't correspond with the user in the database anymore, so we should get an exception, and we do, invalid update token, and if we paste the return one from before, we get a new one back. So just further proving that these update tokens are only one-time use, but they have no expiration date. So through this process, as we grant and create session tokens for users when they register or log in, they will expire every day, and then on the front end, the client will recognize at some point, hey, my session token doesn't work anymore. Let's use this user token that I've cached somewhere to renew my session token with this route, and then they can continue on their merry way, not asking the user for any username or password or anything like that. Yeah. So this is like a generic approach of doing authentication with Flask. We also recommend maybe like trying out OAuth if you're interested. There's some cool libraries out there. If you just Google like OAuth Python, you'll find I think like 2 really popular ones for integrate with that. For the hack challenge, we don't require that you do anything with authentication with your applications, but it's fun. It's there if you want to do it. But we do say like if you do choose to do authentication, please do it after you've actually like finished your application, so that you're not doing all this extra work that doesn't add any like value to using your app first and then like run out of time. So do it after the fact. But otherwise, that's what we have for you today. Hope you enjoyed authentication.